Now you've had a chance to see abstraction in theory. Let's have a look at how it's used in real life with a black hole simulation. So why do we use simulations? Well, the key to a good experiment is to have a well-founded hypothesis of what to expect. But the problem is, when you're dealing with the motions of astronomical size objects, the complexity of the equations to map their motions is actually too large to calculate by hand. So scientists often produce simulations encoding those equations to produce their own expected results with which they can test their theories. Scientists at NASA use simulations of black holes to test theories that would not be possible to test otherwise. So why do we use OOP with simulations? Well, simulations and OOP are a perfect fit. If you think about it, simulations describe real-world events, and OOP was designed based on the fact that all things in reality can be grouped into objects. When we're producing simulations, we can actually represent real-world objects as just computational OOP objects. So, let's look at our mini project, a black hole simulation. We've provided you with a system that will simulate black holes. Your job is to create an abstraction of a particle to go in the system so it can accurately simulate the way that particles interact with black holes. Now, you'll need to think carefully about what attributes of a particle would be important when you're simulating the interactions with a particle between a black hole. Well, there are a lot of attributes that you could apply to a particle. You could give it a molecular composition. You could give it a charge. But if you think about it, given the experiment and the fact that we're discussing a black hole, one of the heaviest things in the universe, I think the mass is going to be slightly more important. Your skill at abstracting real-world objects and selecting only the important features of an object when creating an abstraction will be put to the test. So, without further ado, let's get started.